In this lesson, we're going to talk about two things. First, we're going to talk about another property that you can apply to monomials. We've already talked about how to add and subtract and multiply monomials. And today, one of the things we're going to look at is raising a monomial to a power. So that's going to be your power rule. And then after we look at that, we're going to look at some applications to geometry, how we can apply what we've been learning to geometry. So first, what the power rule looks like is when you have the power rule, you're definitely going to have parentheses. So you're going to have an expression inside that parentheses. That expression may or may not have an exponent, but then you're also going to have an exponent out here. So when you see that set of parentheses and you see the exponent on the outside and inside, or maybe just on the outside, you know you need to apply the power rule. And what the power rule states is, again, just like before, your base is going to stay the same. But then what you're going to do with your exponents is you're going to multiply them. So A times B. So when you're raising a power to a power, you multiply the two powers. So when I say raising a power to a power, A is a power because it's the exponent on X. And then B is a power because it's the exponents on X to the A. So those are two exponents. So power to a power, you have two exponents. And you're going to multiply those two. So when you take a look at number 1, that base is going to stay the same, X. And then you're going to multiply your two exponents, 2 times 5. So that would be X to the 10th for your final answer. Now in number 2, you have two variables. So you want that power that's on the outside to be raised to everything inside your parentheses. So your exponent is going to stay the same for your first one, M. And that's going to be 7 times 4 because of the outside exponent. And then your N variable is going to stay the same. And then that would be to the 4 times 4. So you're taking the exponent that's on the variable in the parentheses times the exponent outside your parentheses. And that would result in M to the 28th, because 7 times 4 is 28, N to the 16th, because 4 times 4 is 16. Now when you apply it to number 3, you want to make sure you remember that C variable, it has an exponent of 1. Remember, everything has an exponent, even if you can't see it. So if you can't see it, it has an exponent of 1. So we're going to do just like we did in number 2. And that outside exponent is going to be applied to everything inside the parentheses. So that would be C to the 1 times 3, D to the 2 times 3. So that inside exponent times the outside exponent, which would result in C to the 3rd, D to the 6th. So those are going to be some of your basic examples. Let's look at it if we have a coefficient. So remember that coefficient, the number in front of it. So what you want to do first is deal with your coefficient first. So raise that coefficient to that given power outside your parentheses, and then do your power rule. So when you look at number 4, you can see it looks different in the fact that we have that 5 coefficient. So the 2 on the outside, the 2 exponents still applies to everything. So it applies to the coefficient and it applies to the x to the 7th. So when we say 5 squared, we can write it like that. And then x to the 7th squared would be x to the 7 times 2, because that's a power to a power. So we multiply those. And we know what 5 squared is. That's 5 times 5, which is 25. And then x to the 7 times 2 is 14. So with your coefficient, you can actually do that math and multiply it out. With your exponent, you're just multiplying the two exponents. So like on number 5, again, that exponent on the outside of the 5 is going to go to the coefficient, and it's going to go to each variable. So that would be 2 to the 5th, then x to the 2 times 5, y to the 1 times 5. Because remember, the y has an exponent of 1. And 2 to the 5th, remember, is 2 times 2 times 2 times 2 times 2, which is 32. And then x to the 10th, because 2 times 5 is 10. Y to the 5th, because 1 times 5 is 5. And remember, for those exponents, we're multiplying them because of the power property. And let's take a look at one more. Let's take a look at number 6, because you can see that coefficient is a negative 2. So my exponent outside the parentheses is a 2, and it will be applied to the coefficient, to my p variable, and my q variable. So when I apply it to the negative 2, so negative 2 squared, we want to make sure that we put that negative 2 in parentheses. And then p to the 4 times 2, because that's power to a power, they're both exponents, and q to the 6 times 2. So negative 2 squared, because we put that negative 2 in parentheses, that's like saying negative 2 times negative 2, which is a positive 4, and then p to the 8th, q to the 12th, when we multiply those exponents. And remember, you're only multiplying exponents when both of your numbers are exponents, power to a power. Go ahead and highlight 7, 8, and 9. And before we look at some geometric applications, let's look at some mixed practice. So, like I said, we have talked about adding, subtracting, multiplying, and now our power property. So we've learned 4 ways to do this, to work with exponents and with monomials. So now with our mixed practice, I can have a combination of any of those ways. So in number 10, you can see I have my power property, because I have my parentheses with an exponent on the outside, and I have multiplication here. So when you have multiple properties going on, you want to make sure you're doing them in the correct order. So for this one, we want to make sure we do our power property first, because you want to think about it like PEMDAS. So please excuse my dear Aunt Sally. And with PEMDAS, we look at our exponents before our multiplication. So the power property is like looking at your exponents. So to apply that power property, we're going to take this 3 on the outside and apply it to both variables on the inside. So that would be x to the 3 times 3, y to the 3 times 3. And I'm going to go ahead and bring down this times xy squared. So when we multiply that, that's x to the 9th, y to the 9th. So when I do the power property, I get x to the 9th, y to the 9th. Then I can take this expression and I can multiply it, but I have to remember my multiplication law. My multiplication property tells me I'm going to add my exponents. So when I multiply exponents, I actually add them. And this x has a 1. So when I add them, that is x to the 9 plus 1, y to the 9 plus 2. Because remember, we're grouping it together by like variables. And we know that 9 plus 1 is 10, so x to the 10th, y to the 11th, because 9 plus 2 is 11. So again, we had 2 properties in this problem. We had our multiplication and our power property, but we're doing them in order of operations. Go ahead and highlight number 11. And go ahead and highlight 12 and 13 and 14. And let's look at 15 together. So in number 15, you can see we have the power property. And we actually have that power property twice, because I have 2 sets of parentheses with the exponents. So I'm going to have to apply that property twice. And then I have subtraction, and I have multiplication. So we actually have 3 of our properties going on in this problem. So let's take it one property at a time. So our power property, the first set of parentheses, I'm going to take this 4 and apply it to everything inside the parentheses. So 3 to the 4th, that's 3 times 3 times 3 times 3 is 81. X to the 3rd to the 4th, so that's 2 powers, 2 exponents, so we're going to multiply those. That would give me x to the 12th. 3 times 4 is 12. And then y to the 4th, because 1 times 4 is 4. Minus, so then I'm going to do my power property again, because I have my exponent with my parentheses with my exponent right there on the outside. So that 2 goes to the 7, it goes to the x, and to the y. So 7 squared is 7 times 7, that's 49. X to the 5th squared, that's 2 exponents, so I multiply them. 5 times 2 is 10. X to the 10th. And then y squared, 1 times 2 is 2. And then I'm going to go ahead and bring down times x squared, y squared. So then from here, again, remember, we're following order of operations. So from here, I have subtraction and multiplication. Well, according to order of operations, I need to do that multiplication first. So I'm going to be multiplying these 2 expressions first. So what that means for this first one is I can just bring down 81 x to the 12th, y to the 4th. Then when I multiply, remember we multiply our coefficients first, and our coefficients are 49 and 1. So that's just minus 49, because 49 times 1 is 49. Then I'm multiplying my x to the 10th times x squared. We're multiplying exponents, so we add, which would result in x to the 12th. And then y squared times y squared. Again, I'm multiplying, so I add. That would result in y to the 4th. 2 plus 2 is 4. Now that I've multiplied, you can see I have subtraction, but remember, we always need to pause here and make sure I can actually subtract. I have to have like terms. And because I multiplied in that previous step, I now do have like terms. I have x to the 12th, x to the 12th, y to the 4th, y to the 4th. So then I can actually subtract just the coefficients. So 81 minus 49 is 32. And your variables and their exponents stay the same. Remember, when we're adding or subtracting, the variable and exponents stay the same. We're just dealing with the coefficients. So with those mixed problems, they can get messy. So just make sure you're showing every step and make sure you're following order of operations. Now let's take a look at a couple of geometric applications. So in these first problems, the directions are asking us to find the perimeter and the area. So when I look at number 16, I have a rectangle, and I'm going to divide my workspace up because I know I'm finding 2 things into a table, where on one side I'm going to find the perimeter, and on the other side we're going to find the area. So I know for the perimeter of a rectangle, I need to add together all of my sides. So I want to make sure I don't forget that on my diagram, I have 2 sides labeled. I'm going to go ahead and label my other side so I don't forget to add together all 4. Sometimes we tend to just add 2 sides, and a rectangle has 4, so we need to make sure we add all 4 sides up. So what that would look like is 12x plus 12x plus 5x squared plus 5x squared. And then we're going to simplify this. So to simplify it, I can combine 12x plus 12x. That would give me 24x. And I can also combine 5x squared plus 5x squared. Because remember, we have to combine like terms. and that would give me a positive 10x squared. So remember, when I'm combining those like terms, I'm just looking at my coefficients to combine them. So my perimeter is 24x plus 10x squared. So with problems like these, it's okay to leave your answer as an expression, because in the original problem, my sides were expressions. I don't have enough information to find the actual perimeter. I can just find an expression that represents that perimeter. Now for area, we have to remember to find area of a rectangle that is length times width. So for this one, I just need two of my numbers, my length and my width, 12x and 5x squared. So to multiply that, I would put both in parentheses, 5x squared times 12x, and then I'm going to multiply my coefficients. So 5 times 12 is 60. And then I'm going to multiply my exponents, or my variables. So x squared times x, remember this x on the second one has a 1. That is going to be x to the third. Because when we multiply exponents, we add them. So our area would be 60 x to the third. Now number 17, it's asking me to do the same thing. So I'm going to set up my work area the same. And on one side, we're going to find the perimeter. And on the other side, the area. And again, for perimeter, it's the same thing for a triangle. We add up all of our sides. The only difference is a triangle has 3 sides. So we're only adding 3 terms. So that would be 4a squared b plus 10a squared b plus 3ab. Now when I go to add these, what I want to make sure I remember is I can only add like terms. So I can only, for this problem, add 4a squared b plus 10a squared b. Because the a squared b is the variable that's the same that needs to be like. And then we look at our coefficients. So 4 plus 10 is 14 a squared b, and bring down the plus 3ab. Now I cannot add the plus 3ab to the 14a squared b, because everything about it has to be exactly the same, the variable and the exponents. So our perimeter is 14a squared b plus 3ab. And again, remember, for these problems, remember that our original problem had expressions for our side lengths. So chances are our final answer is going to be an expression also. We're not looking for one single number or one single term. Now, for our area, we have to remember that the area of a triangle is 1/2 your base times your height. And we have to know that our base is the 3ab and the height is the 4a squared b. We're not going to be using that leaning side. So to find the area, we're going to multiply 1/2 times 3ab times 4a squared b. Now, when we multiply this, what's going to work out the best is if you go ahead and multiply the second term and the third term. Wait for the 1/2 till the end. And remember, multiplication, it doesn't matter what order we multiply in. We want to just work with the easiest way. So we're going to go ahead and bring down that 1/2. And then when I multiply my second and third term, we start by multiplying our coefficients. So 3 times 4 is 12. And then a times a squared. That is a to the third. I have to remember my multiplication law. It means I add my exponents. And then b squared. 1 plus 1 is 2. Again, adding my exponents because I'm multiplying exponents. Then I can take an account for this 1/2. So the 1/2, I'm just multiplying that 1/2 times 12. So 1/2 times 12 is 6. And then bring down your a to the third b squared. So our area is 6a to the third b squared. Go ahead and highlight number 18. And then number 19 and 20. And remember, for 19 and 20, make sure you're reading those directions. 19 and 20 just want you to find the area. And number 19 is a trapezoid, so you'll have to remember the formula for finding area of the trapezoid. And for number 20, you have a circle, so you'll want to remember that formula for finding area of a circle also.